This Zoom session is being brought to you by the Fractal SUS W. Now today, well, we have a scheduling issue. It's like there's like 7 sections left and 4 classes left, and I can make it 2 and 2 and 2 and 1, but that would sort of stretch it out to the end. So I'd like to do today is do 3 sections, partly because the first 2 are relatively simple, and then 2 and 2 and 2. Well, 3, 2 and 2, whatever. Okay. So today we're going to be doing algebra functions and composition. 9.2 will be about inverse functions, and 9.3 will be about the exponential. Now, we start with functions f and g, and we can find their sum, their difference, their product, and their ratio. And functions are defined by how they operate on numbers. So f plus g on x is f of x plus g of x. Similarly, f minus g applied to x is f of x minus g of x, f times g of x is f of x times g of x, and f over g of x is f of x divided by g of x. Now the book goes into some questions about the domains of these things. I tend to leave that alone. The main thing, okay, these have domains where both f and g have domain. This you have to rule out where g of x equals 0. So here we go. Example. F of x is 2x minus 5. G of x is x plus 1. What's f plus g at 8? Well, it's f of 8 plus g of 8. Plugging in here, twice 8 is 16 minus 5 is 11. G of 8, 8 plus 1 is 9. 11 plus 9 is 20. That's f plus g at 8. F times g at 0, well, it's f of 0 times g at 0. At 0, f is negative 5. At 0, g is 1. Negative 5 times 1 is negative 5. Fairly straightforward. All right. So it's what's called termwise. So it's f operate g on x is f of x operate g of x. All right. All right, so here we have s is 3 minus x, t of x is x squared minus x minus 6. What's s times t at negative 2? What's s over t at 1? Well, okay, this is s of negative 2 times t of negative 2. We're plugging in at negative 2. S of negative 2 is 5. T at negative 2 turns out to be 0. So I find 5 times 0 is 0. S over t at 1, well, is s at 1 over t at 1. S at 1 is 2. T at 1 is negative 6. 2 over negative 6 is negative a third. All right. Now, here's something more of interest in the next 2 sections. The composition of functions. F composed with g, also pronounced f of g at x, is f of g of x. You start with x, apply g to it, get g of x. Apply f to that, f of g of x. And that motion here, from here to here, is f composed with g. All right, so for these few, we're going to have, let's see, you're going to have f of x is 2x plus 1, g of x is x squared minus 1. Now here I'm going to do something the book didn't actually ask for. That's find f of g at a half and g of f at a half. I think they only asked for this one, but I'm asking for both. Here's g of f at 2x, here's f of g at 2x. All right, f of g of a half is f of g of a half. G of a half is a half squared minus 1, which is 3/4. F at 3/4 is twice 3/4 plus 1 is 2.5. Right? Oh, yes, it is. Okay, fine. G of f at a half is g of f of a half. G of twice a half of a half is twice a half plus 1, which is 2. G at 2 is 2 squared minus 1, which is 3. You can see that f of g and g of f are not the same. Composition of functions, order matters. Which way order you do something matters. Okay. Here's g of f at 2x. G of f of 2x is g of twice 2x plus 1 is g of 4x plus 1. 4x plus 1 squared minus 1. After a bit of algebra, it's 16x squared plus 8x. Here's f of g at 2x. What's that? Well, f of g of x of 2x is 2x quantity squared minus 1. That's f of 4x squared minus 1. Twice that plus 1. Twice 4x squared minus 1 plus 1 is, do I have that right? Yeah, 8x squared minus 1. And again, you can see that these are quite different. The order matters. It's called non-commutativity. Okay. Here we have f of g at 4, g of f at 4. Okay, f of g at 4. G at 4 is 4 squared plus 4 is 20. F of 20, 3 times 20 minus 2 is 58. G of f at 4. G of f at 4 is g of f of 4 is 3 times 4 minus 2. 12 minus 2 is 10, so this is g of 10. G of 10 is 10 squared plus 10 is 110. Again, quite different. And g of f of x is g of f of x is g of 3x minus 2. So it'll be that squared plus the same thing, which after simplifying is 9x squared and minus 9x plus 2. I forgot to get f of g at x, but it'll certainly be a different expression. All right, here we're going to ask to prove, because f of x is x plus 1 and g of x is 2x minus 5, prove that f of g is not the same as g of f. F of g at x is f of g, which is 2x minus 5. F of that is that plus 1. 2x minus 5 plus 1 is 2x minus 4. Whereas g of f of x is g of f of x is x plus 1. G of that is twice that minus 5. 2x plus 2 minus 5 is 2x minus 3. 2x minus 4 and 2x minus 3 differ by 1, so they are not the same. Okay, and stopping this.